All right, this is a calculation on chemical composition stoichiometry involving purity of samples. A sample of copper 2 oxide, formula provided, is only 40% pure. This is percent purity of the sample. What mass of the sample would contain 2.50 grams of the oxygen? Beautiful. Now we have to establish that the sample provided contains the copper 2 oxide, CuO, which in turn contains the oxygen provided. The sample is the whole bulk, which is 100%. The copper 2 oxide is simply 40% of that bulk. And by virtue of its molar mass, we can draw the relationship between copper 2 oxide and oxygen. Copper 2 oxide contains oxygen. So this is going to be a calculation involving 3 units. 1, 2, copper 2 oxide, and 3, the oxygen. So let us get straight off into it by taking off these traces. The solution straight away. First, we establish the molar mass of copper 2 oxide. Here we go. Molar mass of copper 2 oxide is going to be the relative atomic masses are provided. For copper, we have 64. This is, of course, an approximate value because we're dealing with a multiple choice calculation. Otherwise, we would have been given the exact value, 63.5 from the periodic table. But this is okay for this calculation, plus relative atomic mass of oxygen provided, 16. Upon addition of these values, we have 80 grams per mole. Now, this means out of the 80 grams in 1 mole of copper 2 oxide, 16 grams is contributed by oxygen. We have to note this. 16 grams is contributed by oxygen. So let us note this here. This is the mass due to oxygen. And that draws a relationship immediately. 60 grams of oxygen is present in 80 grams of copper 2 oxide. We're going to make use of this in our dimensional analysis. So let us start it straight off. Starting from the given value, 2.50 grams of oxygen. Let's go. Therefore, we have 2.50 grams of oxygen. And now we're going to multiply in such a manner that we can cancel this unit, gram of oxygen. To cancel that unit, it has to happen in the denominator. So we have to provide gram of oxygen here, and we make use of the relationship. 16 grams of oxygen, 16 grams of oxygen is present in 80 grams of copper 2 oxide. So 80 grams of copper 2 oxide. Beautiful. And now we need to cancel also the gram of copper 2 oxide. The relationship between the sample and copper 2 oxide will provide that. Copper 2 oxide only makes up 40%. Gram copper 2 oxide contained in the full mass, 100% gram of the sample. Beautiful. And now this is mission completed already because we have gram of oxygen eliminating gram of oxygen, gram of copper 2 oxide eliminating gram of copper 2 oxide. And after taking off the percentages, the surviving unit here is gram of the sample, which answers the question, the mass of the sample. Beautiful. And now, with the aid of an electronic calculator, we multiply out these values, 2.50, 80, and then divide appropriately. We're going to come up with our final answer, which is 31.25 grams of the sample. And this, of course, is our final answer. Very simple. And that is right there in the option C. Now, attached to this video are 2 quizzes that I recommend you take in order to test your understanding of the content of this video. You can click on the answers and learn more from the quizzes. Now, there is also a link attached in the pinned comment that takes you to the full test, a comprehensive test on chemical composition stoichiometry. This will help you establish your understanding or mastery of the topic. I recommend you take the test. There are 20 questions to be taken in 30 minutes. Finally, there is need for further study, so you can study the full analysis of chemical composition stoichiometry provided in the link in the pinned comment. Thank you for being part of this session. And of course, I will see you in the next video.